Let's talk about linear functions. So the next video we'll get into some things about nonlinear functions, but right now let's talk about linear functions. There's two types of data that can make up linear functions. One is continuous data, and continuous data can take on any value, so no space between data values for a given domain. What that looks like is a line. So for linear functions, a line would look like this. A straight line going up, straight line going down, straight line horizontal, or a straight line vertical. Those are our options. We're not going to have ranging lines. We're not going to have lines that are not straight, that change direction. We're not going to have dots like this. We're not going to have steps like this. It's going to be a straight line, continuous data. That wasn't super straight, but a straight line. Discrete data has space between possible data values. So discrete data would look like this, having dots at our data points and not a line connecting them. Just dots that represent our data points. So let's take a look at a couple real-world examples here. So continuous data, an example is the number of ounces in a glass. Number of ounces in a glass. So if we have a glass, of something, whether it's water, milk, juice, whatever it is, if we have a glass that's filled up with some kind of liquid, the number of ounces or the amount of fluid in it could be different. We could have this much, 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 right? We could have a little less, we could have one single drop, we could have a little tiny bit, we could have nothing. So we could have infinite different amounts within this container, not infinitely increasing amounts, but infinite amounts that would fit in this container we could have. This could be an infinite range of decimal values that would fit inside of this container. So the number of ounces, we can't count how many ounces would be in this glass. We could count how many whole ounces. So maybe this is 1 ounce, this is the 2 ounce level, this is the 3 ounce level, 4 ounce, so on. Maybe this is an 8 ounce glass. So if it was all the way filled up, it would have 8 ounces, and if it was filled up to any of these levels, it would have that amount of ounces, whole ounces. But in the sense of talking about this and thinking about how many ounces are in the glass to the exact amount, to the decimal value, this would be continuous. We could say that there's half an ounce, we could say that there's 1 whole ounce, we could say that there's a quarter, an eighth, we could say there's a 16th, we can say that there's a number between a quarter and a half, and we can say there's a number between that and a number between that. There could be any range of these ounces inside of the glass. The weight of each chocolate chip. If we have a chocolate chip, the weight of this chocolate chip could be anything. It could be half an ounce. It could be a quarter of an ounce. It could be 1/8 of an ounce. Again, we could have any range of ounces here. We could have 0.49 ounces or 0.48 ounces or 0.485 ounces. We could have any range of ounces for the weight of each chocolate chip. So since this is an infinite amount of values, we're going to have a continuous line for this. For the discrete data, the number of glasses in a cupboard, if we picture a cupboard and we have items in this cupboard, maybe glasses, cups of different sizes, whatever it may be, we can count them. We can count, oh, there's 1, 2, 3, 4, 5. Or this other cupboard might have 1, 2, 3. Might only have 3. So we could say that in one cupboard there's 3 glasses, or there's 5 glasses, or there's 4 glasses, or there's 2 glasses. Whatever that number is, we can draw discrete points, a non-continuous line, because we can either have 2 glasses or 3 glasses or 4 glasses. We can have a whole number of glasses, but we can't have a half glass or a quarter glass. If we have a cup or a glass, we have a whole number of those values, whole number of glasses. And the number of chocolate chips in a bag, same deal. If you have chocolate chips in a baggie, you can count them. I can count, in this case, there's 1, 2, 3, 4, 5, 6. There's 6 in here. If we have a different number, there can be a different number. But again, it's going to be a whole number of chocolate chips. We can't have a half chip. You might see a chip that's broken up, and so you would call that a half chip. But in the sense of talking about discrete data, you can count how many chocolate chips there are in here. There's not going to be infinitely many uncountable chocolate chips. There's going to be a countable amount. Even if that amount is infinite, there's going to be a countable amount. It's not going to be uncountable. So we can count these chips, and we can place these discrete values on a graph. We can place them with spaces. They're not going to be, it's not going to be a straight line with no space. It's going to be places.